I'm going to put a tick mark on these to show you that the radii are all the same length. The point of having this circle is to show that it's equidistant from the vertices, that this circumcenter is the same distance to that vertex as it is to each of the other vertices, because it's the center of the circle, and the radii of the same circle are all the same. So the point of the circle is to show you that the circumcenter is equidistant from vertices. So if you see a triangle with a circle on the outside, that is showing you the circumcenter, because the circle is showing it's equidistant from the vertices. Okay? All right, now pick up or go to page 58, where you have your incenter. And the incenter is made of angle bisectors. So right underneath your picture, I want you to write angle bisectors, cut an angle in half. Angle bisectors, cut an angle in half. And I want you to draw an angle and then draw an angle bisector that looks like it's cutting in half. You can just eyeball it. And if we're going to show that this angle's been cut in half, we're going to put an arc there and an arc there to show those two angles are congruent. So grab a highlighter and highlight here and here. When you have a triangle, and I'm going to make this into a triangle so y'all can see what the picture will look like. When you have a triangle where you've got an angle bisector, this is showing you that the point of concurrency is going to be the incenter, because you've got these two arcs here that are the incenter. Okay? Now find your pretty picture and hit pause if you need to cut it out. And you're going to tape this right underneath incenter. So we have incenter was made by angle bisectors, and we learned that the incenter is equidistant from the sides of the triangle. So see right here, you've got, we drew these segments, and these orange segments were all the same because the incenter was the same distance to each side. So when you look at this picture, do you see how we have a circle on the inside of the triangle now? The incenter is the center of that circle, and when I draw this radius right there, and this radius, and that radius, I drew them so, I kind of eyeballed it, but I drew them so these are all right angles. These segments are all congruent because they're radii of the same circle. So when you see a triangle with a circle on the inside, it's showing you that the incenter is the same distance to each side. So it's equidistant from sides. Equidistant from sides. So when you have an incenter, sometimes you'll see a circle on the inside of the triangle. That's showing you that the incenter is the same distance to each side of the triangle. Okay? Now, before we go on to the other two triangles, I want to show you a little trick. We have circumcenter and incenter. And the circumcenter is equidistant from vertices, and the incenter is equidistant from sides. Here's how I remember it, and you can remember it however you want to. Circumcenter is a longer word out of incenter. Circumcenter is a long word, incenter is a short word. When you're looking at vertices and sides, vertices is a long word, sides is a short word. So I remember that long words go together and short words go together. You can also remember that the incenter has a triangle, the incenter has a circle on the inside. Incenter has a circle on the inside, and since it's on the inside, it's showing that it's the same distance to each side. The circumcenter has a circle on the outside. This one's harder to draw. And the reason it's on the outside is it's showing the circumcenter is the same distance to each vertex. So this one's the incenter, that's the circumcenter. You can also remember that I and S make the word is. So you can remember in center is equidistant from sides because it makes the word is. Whatever works for you, whatever thing you can use to remember, that's what you need. But you just need to know that vocabulary. Circumcenter is equidistant from vertices. In-center is equidistant from sides. Okay. Now turn to page 59. And we're going to look at our centroid.